Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today we are going to chapter constructions. Before delving into the chapter, let us first understand few basic constructions. Like number one, we need to know how to construct a bisector of an angle and how to construct a perpendicular bisector and all that. Let us start with the angle bisector. For example, if you have given any angle, say for example you constructed some angle. Let us say you constructed some angle like this. Now you need to bisect this angle. You need to draw the angle bisector of this angle. That means a ray which divides this angle into two equal angles. So what we do, we first draw, we take with this point as center. For example, this is OAB. Angle AOB is, for example, some angle, say 60 degree. Now we are going to draw the angle bisector of this angle. With O as center, draw an arc of any convenient length like this, intersecting the arms of this angle at two distinct points. Then, with this point as center, radius more than half of this arc, draw an arc. With this as center, same radius, draw another arc intersecting the previous arc. Then join O and this point, and this will give you angle bisector of this angle AOB. Hence, this angle is equal to this angle. This is an angle bisector. So this was construction 11.1. Then we have construction 11.2 to construct the perpendicular bisector of a given line segment. If you have a line segment like this, for example AB, now you are required to draw the perpendicular bisector of this AB. What you're going to do, with A as center, radius more than half of AB. With A as center and radius more than half of AB, draw an arc here and here. Then with B as center, draw another arc intersecting the previous arc at two points. Then join this and this. Join this point and this point. Now this line intersects the line segment AB at some point, say O. Now AO will be equal to OB because this line bisected AB. And also you will find that this angle will be equal to 90 degree. So it is a perpendicular as well as bisector. So that's called perpendicular bisector of a given line segment. Then we have now let us start exercise 11.1. Construct an angle 90 degree at the initial point of a given ray and justify the construction. So we are going to construct an angle of 90 degrees. See how it's done? It's very easy. What you'll do, first of all, at an initial point of the given ray. So let us say this is a ray OA. Let us say this is a ray OA. Now you are going to draw a 90 degree angle at this point, initial point, because when you draw a ray, there are 2 points. One is this point, this is called starting point or the initial point, and this point is called the terminal point. Now, because ray has a one end point, you know that. With O as center and radius, and with O as center and any convenient radius, draw some arc like this. Intersecting OA at some point, say B. Now with B as center and the same radius, do not change the radius now. With B as center, same radius, draw an arc intersecting the previous arc at some point, say C. So you'll get something like this. And remember, this point, if you join OC, then draw a ray, that will give you 60-degree angle. Then with C as center, let us join it dotted. This is a 60-degree angle. Then with C as center and the same radius, draw another arc. Draw another arc intersecting the first arc at D. Got it? Now if you join OD, then if you'll establish a ray, then this angle AO something here, you'll get angle 120 degree. So this is your 120 degree. This is your 120 degree. Then what you'll do with C as center and radius more than half of this DC arc. With C as center, radius more than half of arc DC. Draw an arc. So that will give you something like this. With D as center and the same radius, draw another arc intersecting this previous arc at some point. So you'll get, now join that and that. You'll get something like this. So this angle is 90 degree. Name this E. Now angle AOE is 90 degree. So that's it. Now if you are about to find the bisector of this 90 degree, so you'll do the same thing what I just showed you first. You'll bisect this. If this is 90 degrees, so this is an arc of 90 degrees. So bisect this arc with this as center, radius more than half of this arc here. So with this as center here, so that will give you the bisector of this angle AOE. So bisector of 90 degrees, 45 degrees. So you'll get the bisector of 90 degrees. Similarly, you can do 45 degree, 30 degrees, the bisector of 60 degree. You can do similarly 15 degrees, the bisector of 30 degree. Then 22 and a half. 22 and a half is bisector of 45 degree. Bisector of 45 degrees, 22 and a half. So it's easy. 15 degree, easy. 75 degree. See 75 degree how it's done. For 75 degree, when you reach 90, then you'll bisect the 60. This is the ray of 60 degree. This is the ray of 90 degree. Now, for this, draw arc like this, or you can use this one. And with this as center, bisect this one. With this as center, one arc here. With this as center, one arc here. So you'll get something like this. So this angle is your 75 degree. Got it? Then similarly you can do 105. You can do 105 like this. This is your 90. This is your 120. Now bisect this. You'll get 100. Similarly 135. Go for 150. Then 150 between 150 and draw first this. This is 180. Extend this line AO. Go here. This is 180 degree. Now bisect this 100 arc of 180, arm of 180 and arm of 120. This was the arm of 120 degree. This is arm of 180 degree. This is arm of 90 degree, arm of 75 degree, arm of 60 degree. Now this is 0 degree. Now arm of 120 and 180, bisect this, you will get arm of 150 degree. Then bisect arm of 120 and 150, you will get 135 degree. Got it? Sorry, you will bisect this, so you will get like this. So this is arm of 135 degree, so this whole angle is 135 degree. Then you are, next question is construct an equilateral triangle given its side and justify the construction. You're going to construct an equilateral triangle, that's easy, I think you can do that one. Now comes the important part, that is exercise 11.2. Exercise 11.2. Construct a triangle ABC in which BC is equal to 7 cm. Question number 1. It says construct a triangle ABC. Let's have a rough sketch first. Let's have a rough sketch. Construct a triangle ABC. So you are going to construct triangle ABC in which BC is equal to 7 cm. This is 7 cm. Angle B is equal to 75 degree. AB plus AC is equal to 13 cm. AB plus AC, sum of these two sides is 13 centimeter. Let us construct this thing. Here I'll show you steps to construction. How will you proceed? Steps to construction. First of all, step number 1. Draw a line segment BC. Or before that, do one thing, or yes, you can go like that. Draw a line segment BC. So if you observe carefully what is given first, let us first analyze what is given. We are given with a base, we are given with base angle, base angle and sum of two remaining sides. Sum of two other sides. So first of all, draw a line segment BC. Draw a line segment BC of length 7 centimeter. So first of all, you are going to draw a line segment BC of length 7 centimeter. Line segment BC of length 7 centimeter. Then at B, make an angle of 75 degree. At B, make an angle of 75 degree. And you know how to draw an angle of 75 degrees. See, first of all, I'll draw one arc. Then with this as center, I'll draw one. This is your 60. Then with this as center, draw one more. This is your 120. And this with this as center, one here. With this as center, one here. This is your 90. Now let us have some dotted gray for 90 degree. Then with the arc of 60 and this one, where ray of 90 intersected the main arc. With this as center, draw one arc. With this as center, one more arc. Then when you join, you'll get 75 degree. Got it? Let me name this as X. So at B, make an angle of 75 degree such that angle CBX such that angle CBX is equal to 75 degree. Next one. After that, what you'll do, and now next thing you can do, you'll cut a line segment BD. Oh, sorry, BX. I named it X. Now, with B as center and radius the sum of those two given sides. What was the sum of two given sides? It was 13. Was it 13? Yes. It was 13, yeah. Now, with B as center and radius with B as center and radius with B as center and radius 13 centimeter. Why 13 centimeter? As AB plus AC, as AB plus AC is equal to 13 centimeter. With B as center and radius 13 centimeter, draw an arc intersecting BX at BX at say some point y, intersecting bx at y. With BS center and radius 13 centimeter. Why 13? Because AB plus AC is equal to 13. Draw an arc intersecting BX at Y. So you'll go like this. Say this is your Y. Got it? The next is join YC. Now join YC. Join YC. Then the next one. Draw a perpendicular bisector of YC. Draw a perpendicular bisector of YC intersecting BY at E. Draw a perpendicular bisector of YC intersecting BY at A. So perpendicular, you need to draw a perpendicular bisector for YC with Y center, one arc here, one arc here. So you'll get something like this. See, I'll make it dotted. You'll get something like this. With Y center, one arc here, one arc here. With CS center, intersect that arc and that arc. Got it? Now, what I said, draw a perpendicular bisector of YC. So this is a perpendicular bisector for YC. Intersecting BY at some point. BY at some point, say that point is A. And that is our A. Now lastly, join AC. Join AC. Hence ABC is your required triangle. Therefore, triangle ABC is a required triangle. Hence, constructed. Now, when you check whether your construction is correct or not, what you will see, this is a triangle A, B, C. This is a required triangle. A, B and C. You will see AB plus AC. Now, major AB, you'll get something. Major AC, you'll get something. Now, add these two results, you'll get 13 centimeter exactly. And this is 75 degree and this is 7 centimeters. So, this proves your construction. Kindly make a note. Now question number 2. Question number 2 says construct a triangle ABC in which BC is equal to 8 centimeter, angle B is equal to 45 degree and AB minus AC is equal to 3.5 centimeter. So if I would draw a rough sketch, I need to construct a triangle ABC with BC is equal to 8 centimeter, angle B is equal to 45 degree, AB minus AC is equal to 3.5. AB minus AC is equal to 3.5 centimeter. This minus this. Now what is the difference? Previously it was base angle and sum of two other sides. Now it's base angle and the difference of two sides. number 1. Steps to construction. Step number 1. What we'll do first, let us first draw a base BC. Draw a line segment BC of length 8 centimeter. Draw a line segment BC of length 8 centimeter. So like this, BC 8 centimeter. At B, make an angle of 45 degree. At B, make an angle of 45 degree such that angle CBX is equal to 45 degree. So you go like this. Then with this as center, this is your 60, this is your 120. This is your 90, now bisect 90, you'll get 45. With this as center, this as center. And we name it X. And this will be your 45 degree. Got it? With this as center and this as center. We are already done how to draw a perpendicular bisector. Now the next step. Now what I'll do, with B as center, previously if you remember what we did, with B as center and radius the sum of two sides. Now with B as center, radius the difference of two sides. With B as center, let me tell you one more thing. There are two cases possible when you go for the difference of two sides. Because addition is commutative, you know that if I have addition of two sides, two remaining sides, whether you say this plus this or this plus this, that's one and the same thing. However, when you go for difference of two sides, you say AB minus AC, it's different from AC minus AB. Because larger minus smaller, smaller minus larger. So there are two cases possible. We are doing case number 1 where we are having larger minus smaller. And then this construction holds true for larger minus smaller, not the vice versa, smaller minus larger. We'll do it in next question. With B as center and radius, take B as center and radius the difference of two sides. What's that? 3.5. And radius 3.5 centimeter. Why? Because it's as AB minus AC is equal to 3.5 centimeter. With B as center and radius 3.5 centimeter, draw an arc intersecting BX at some point say Y. So we'll go like this. bisector and radius 3.5, draw an arc. So let us say this point is Y. Now after that, join YC. Join YC. Join YC. Now next thing is draw a perpendicular bisector of YC. Draw a perpendicular bisector of YC. Draw a perpendicular bisector of YC. It's quite similar to the first one. Draw a perpendicular bisector of YC intersecting BX. Intersecting BX at A. Intersecting BX at A. Now draw the perpendicular bisector of this. That will intersect. That will go like this. So you'll get something like this. Perpendicular bisector of YC intersecting BX at A. Then join AC. Join AC. Join AC. Now ABC is your required triangle. Therefore, triangle ABC is a required triangle. Hence, constructed. Now to check, you know that BC is 8 cm, angle ABC is 45 degree. Now to check, you will see you measure AB, then measure AC, then do the difference. AB minus AC, you'll get exactly 3.5 cm. Make a note. Now let us do question number 3. Question number 3 is the case 2 of question number 2. Construct a triangle PQR. So we are going to construct triangle PQR. Angle Q is equal to 60 degree. This is 60 degree. PR minus PQ. Now it's PR minus PQ is 2 centimeter. How would you draw that? One more point is here. What is the difference between these two cases? Number one is you are taking first that side which is included in the angle, base angle. So minus the remaining side, and this is the opposite of that. First of all, let's have the first point. Base angle is QR is equal to 6 centimeter. So do it in the same way. Draw a line segment QR of length at Q, make an angle of 60 degree. Make an angle of 60 degree such that angle RQX is equal to 60 degree. So it's like this. Like this. First arc, then with this as center and same radius draw an arc, then join Q at this point, you'll get this X. So RQX is 60 degree. So you're good with 60 degree. Now the next thing, what we did previously, we with Q as center and radius the difference of 2. Now this time do the same thing, but do it in the opposite way. Extend QX. Extend QX to Y. Extend QX to Y. Extend QX to Y by the other side of X. This is one side, this is the other side, by the other side of X. So you got like this. Now with Q as center and radius, now do the same thing with Q as center and radius. With Q as center and radius, the difference of 2, what is that? 2 centimeter, and radius 2 centimeter. Draw an arc. Why 2 centimeter? Give the reason. As PR minus PQ is equal to 2 centimeter. Draw an arc intersecting QY, intersecting QY at some other point, say Z. So he'll go like this. Separate like this. This is your Z. With Q as center, radius 2 centimeter, draw an arc intersecting QY at Z. Now next step, join ZR. Join ZR. Now the next one, draw the perpendicular bisector of ZR. ZR. Draw the perpendicular bisector of ZR. Intersecting XY at A. Draw a perpendicular bisector of ZR intersecting That will give you something like this. Perpendicular bisector for ZR intersecting XY at, this is your A. Now join, sorry, this is your P. Join PR. This is P. Then seventh is join PR. So PQR is your required triangle. QR is base 6 cm, angle Q is 60 degree, and you'll check PR minus PQ. You'll get 2 cm. Hence, constructed. Make a note. After that, next question, question number 4. Construct a triangle XYZ in which angle Y is equal to 30 degrees. Very important question. Construct a triangle XYZ. So we have triangle XYZ. Angle Z is 90 degree. X, Y, Z. Angle Y is 30 degree. Sorry, write down like this. X, Y, Z. This is 30 degree. Let me make it like this. X, Y, Z. This is 30 degree. And this is 90 degree Z. And XY plus YZ plus ZX is equal to 11 centimeter. Perimeter. Perimeter of triangle XYZ is equal to 11 centimeter. Because sum of all sides of a triangle is a perimeter. So perimeter of triangle XYZ is 11 centimeter. That's it. So you need to construct this thing now. Step number 1. First of all, draw a line segment. Say some PQ. Because XY should be PQ. Draw a line segment. Draw a line segment. Whenever you are required to construct such questions, what you'll first see what is a perimeter. Now construct a line segment equal to that perimeter. Draw a line segment PQ of length 11 centimeter. Why 11 centimeter? As XY plus YZ plus ZX is equal to 11 centimeter. This is a reason why you are drawing 11 centimeter PQ. So go with it. P, Q, there's no need to write that one. Now, next step, at P, make an angle equal to Y. At P, make an angle of 30 degree such that name that R, such that QPR, angle QPR is equal to 30 degree. Now let me make 30 degree here. bisect this, and 30. Make it dotted. This is your 30 degree. At this is say no. At Q, do the same thing at Q, make an angle of 90 degree. Make an angle of 90 degree such that angle S PQS such that angle PQS is equal to 90. Now make 90 degree here. This is your S and this is 90 degree. Now bisect angle QPR. Bisect angle QPR such that angle QP something here RST bisect or you can write like this, draw an angle bisector of angle QPR and right angle bisector of angle QPR, right angle bisectors of angle QPR and angle PQS. Triangle bisector of QPR, this angle, triangle bisector of PQS, this angle. Now surely they will intersect somewhere. Let us say that point is X. That point is our X. So we got our X. Draw an angle bisectors of QPR and angle PQS such that, or you can say intersecting each other at X such that angle QPX is equal to 15 degree and angle PQX is equal to 45 degree. Did you get this one? Angle bisector of this 30 degree, so that's 15 QPX, and angle bisector of PQS, that's 45. So these angle bisectors will bisect at somewhere. Let us say that point is X. That's it. So you will go like this. Go dotted again, just like this. Now the point of intersection, this point of intersection is your X. Then It's like this. So PX is the bisector of angle QPR and QX is the bisector of angle PQS. Now the next thing is draw a perpendicular bisector of PX and XQ. Perpendicular bisector of PX, perpendicular bisector of XQ. Draw a perpendicular bisector of PX and QX. Perpendicular bisector of PX. That will go like this and it will intersect PQ at some point. Let us say that point is a Y. And perpendicular bisector of QX will intersect QP at some point and that point will be our Z. Draw perpendicular bisectors of PX and QX intersecting PQ at PX will intersect at Y and QX will intersect at Z, Y and Z respectively. So it will go like this. So we'll get like this. This is a perpendicular bisector of PX intersecting PQ at Y. And this is a perpendicular bisector of QX intersecting PQ at Z. Now all you need to do is just join XY, join it with borderline and join XZ. Join XY and XZ. Therefore, triangle XYZ is a required triangle. XYZ is a required triangle. Now, how would you check this? This angle? This angle is 30 degree. This will be on 90 degree. If you check it with protractor, this will come 30 degree. This will come out to be 90 degree. And sum of these three sides, the perimeter of this triangle, you will get exactly 11 centimeter. Hence, construct. Make a note. Now let's have the last question of this exercise, rather this chapter. Question number 5. Construct a right triangle whose base is 12 centimeter. So you are going to construct a right triangle whose base is 12 centimeter. Let us say this is 12 centimeter base. And sum of its hypotenuse and other side is 18 centimeter. Sum of these two sides is 18 centimeter. Hypotenuse and remaining side is 18 centimeter. Okay, that's it. So let me name it something, say A, B, C. So let us construct this triangle ABC. First of all, what you do, if you observe carefully, it is exactly like the question number 1. Because base is given, base angle is given, and the sum of two remaining sides is given. So what we'll do? Construct a line segment AB. I'll make it the mirror image. image of this AB 12 centimeter. Let me go like this. BA. No, it's good. A B. Let me make it in this way. AB is 12 centimeters. So I'll write draw a line segment. Draw a line segment AB of length 12 centimeter. Draw a line segment AB of length 12 centimeter. Then the second step, at B make an angle of 90 degree. At B make an angle of 90 degree such that angle AB x is equal to 90 degree. So it will go like this. It'll get like this. This is 90 degree. We just learned about that angle. So it's ABX 90 degree. This angle is 90 degree. Now, next step, what you'll do with B as center and radius the sum of two sides, that means 18 centimeter, with B as center and radius 18 centimeter. Why 18 centimeter? As AC plus BC is equal to 18 centimeter. Draw an arc intersecting BX at, say, Y. Intersecting BX at Y. So with B as center and radius 18 centimeter, something like this. Say this point is Y. Then join YA. Join YA. The next step is join YA. Now you got this YA. After that, what you'll do, draw a perpendicular bisector of AY. Draw a perpendicular bisector of AY intersecting. Now draw a perpendicular bisector of AY intersecting BY at C. Perpendicular bisector of AY that will intersect BY at some point, and that will be our point C. So you'll go like this. So you'll get something like this. Perpendicular bisector for AY intersecting BY at this point is our C. Then all you need to do is just join AC. join AC. Therefore, triangle ABC is a required triangle. Hence, constructed. Now, if you could prove this, you can prove this like this. AB is base, that's 12 centimeter. You just drew it 12 centimeter, then base angle is 90 degree, you know that. Now all you need to do is just add AC plus BC, you'll get exactly 18 centimeter. Did you get it? Kindly make a note. See you next time. Assalamu alaikum wa rahmatullahi wa barakatuh.